Okay, welcome back to Microeconomics. In this video, we're taking a look at a few Chapter 2 examples. Specifically, we're taking a look at the relationship between isocosts and the choice of technology. We're going to be taking a look at, I believe, 3 examples altogether. So let's jump over and have a look. Okay, so here's our first example, question 2.9. We have a table. It says, hey, this table gives different technologies that produce 100 meters of cloth. Based on this information, read the following statements and select the correct ones. We have, you would never choose technology B. Okay, right here, I'm going to stop. Truthfully, there's ways that you can visualize this in your mind. For myself, I'm going to stop, grab a pen and paper, well, in this case, virtually, and I need to actually see this, plot this, to see what's going on. So let's go do that quickly so that we can actually visualize what we're looking at, not just rely on a table. So let's take a look here. We'll have our vertical axes and we'll have our horizontal axes. We'll call the vertical axes the amount of coal we need, and the horizontal, the amount of workers, the amount of labor. Let's take a look now at where each of these points, each of these technologies fall. So technology A needs 1 worker, 7 coal. So something like that. That is our technology A. Okay, what do we have next? Technology B requires 3 workers, but 6 coal. So I'm going to say B, maybe somewhere around there. That's going to be B. Maybe that. There we go, B. Okay, technology C, where is that? 2 workers. Okay, so a little bit less workers, but more coal. Oh, no, sorry, less coal. Somewhere like that. 2 workers, 5 coal, and that is technology C. Technology D, where does technology D fall? Technology D requires 5 workers, so now we're somewhere over here, but it only requires 1 coal, so not too energy intensive. That's going to be technology D. And then finally, where's technology E fall? Well, technology E requires 7 workers, so we're going to be somewhere over here, and 3 tons of coal. That's going to give us something like that. Okay, now that we have this all plotted out, we can take a look at it and see what's happening. And right away, taking a look at that, I can go, hey, that first point there, you would never choose technology B. Oh, 100%. That is a true statement. And hey, Keith, how do you know that's a true statement? Well, what we can take a look at is going back to this, and we can say, knowing that our isocosts have to be downward sloping. Now, keep in mind, downward sloping means they could be vertical, they could be horizontal, or they could be any bit of downward sloping in between. So, okay, needs to be one of those kind of shapes. Let's just get rid of that so that we can actually play around and visualize. Okay, there we go. So what I can do, let's just change colors so that it's not mucking it up too much, is I can say, is it possible for any isocosts that we face for B to be closer to the origin than C? And so going from C, I can go vertical line up, I can go horizontal line across, and what we see is that no matter what, B is always up and to the right of any possible isocost that could flow through C. So in this case here, B is entirely and always dominated by technology C. So no, there's no way that we would ever choose B. To be honest, we could say the same thing about technology E. Technology E is always dominated by technology D. So again, B, that's a no-go. E, that's a no-go as well. We would never ever choose one of those technologies. We would be just choosing truthfully between A, C, and D. Okay, what can we go through next? Technology C is more energy intensive than A. Okay, well, let's, sorry, I've lost track of it. Where is C? Where is all of them? Let's just rename them. So A, that was B, this guy was C, and this guy over here, that was D. Okay, so we're saying that C is more energy intensive. Well, coal, that's our energy source. No, C is not more energy intensive. A is definitely more energy intensive. So this is a false statement. Okay, so far we're selecting the first box only. Let's see, shifting from technology C to technology D saves labor. Well, okay, I mean, hopefully that's pretty instantly clear that that's not true. Technology C only uses 2 workers. Technology D uses 5 workers. So no, technology D does not save labor. Technology D uses 3 more workers. So that's a big old F as well. Not true. That guy's false. Finally, last guy there, technology D uses the least number of workers and tons of coal. Therefore, this is the technology we would choose. No, that's again not true at all. As we take a look, depending on these isocost potential slopes, so depending on the relative cost of the price of coal and your wage rate for labor, we may be picking A, we may be picking C, we may be picking D. And so really couldn't say which one wins out. And again, we can just take a look at extreme cases to visualize that. Let's say we had these vertical isocosts. Well, if we had these vertical isocosts, there we go, and these blue lines here, these are supposed to be vertical. We see that technology A would be closest to the origin. Technology A would be the cheapest to utilize there. This would be, yeah, so we'd use technology A. But of course, what if the opposite was true? The opposite extreme, of course. What if we had a case where we had near horizontal isocosts? Well, in this case, near horizontal, they'd go all the way through. And this case here, we see that technology D is closest to the origin, and thus we would choose technology D. Of course, finally, we do have that in-between case, which is realistically more where we're at. We have a downward sloping A, we have a downward sloping C, and we have a downward sloping D. In this case, C is the closest to the origin, so C is the lowest isocost, and thus again, similarly, would be the technology chosen in that case. So again, all dependent on the relative ratio of price and wages, and given the information we have, we really can't be sure which technology for sure will be chosen. All of that to say, that fourth item there, that fourth possible combination, that is also false, meaning it's only the first option there which is true for us. Okay, hopefully that helped. Let's go take a look at the next page. Let's take a look at the next question to consider on this topic. Okay, so this one's getting a little bit mathy. We have production of cloth requires 2 inputs, L, the number of workers, so labor, and R, which is our tons of coal, our resources we need. The isocosts are given by the following equation. C, that is our cost, is equal to the wage rate times of our labor, plus the price of the coal times the amount of coal, the amount of resource we're using for different total costs, C. We're saying that the wage rate is W and P is the price of coal. So the wage rate is 20 and P equals 10. The cost associated with a particular isocost is C equals 40. Okay, so we have a cost of 40. Let's read the following statements and select the correct ones. We will assume that the number of workers is on the horizontal and coal is on the vertical. Okay, let's see what we have here. So what the heck do we do with all this information? Well, okay, what I'm going to do is, again, I'm a visual person. I find in economics it's better just to put stuff on the paper and see what you have to work with and then start working on it. So let's start off. It says, hey, assume the number of workers is horizontal, coal is on the vertical. So let's do that to start us off. Let's make that maybe a bit bigger. There we go. And then horizontal, there we go. Let's label our axes so we know what we're talking about. This is coal. This is the number of resources that we need. This is L, the number of workers, the number of laborers we need. Okay, then what do we know? We have from up here that cost is equal to WL plus PR. So let's write that down, but let's substitute in that wage equals 20, price of coal is 10, and that we're doing this for an isocost of 40. So, okay, what does that give us? That gives us that 40 equals wage times labor. Well, we know that wage is 20 labor plus, what's the price of coal? Price of coal is 10, and then that was 10, price of $10 is the price of coal times the amount of coal. R is the resource, the amount of coal that we need. So cool, we have this function here, but what exactly do we do with it? Where do we go from here? Okay, what I want you to remember is that the slope point intercept form of a line, I butchered that name, but hopefully you get what I mean, is y equals mx plus b. Mind you, this could be written the other way too. This could be written as y equals b plus mx. That's same thing, just written in two different ways. What's the important part here? Well, what are each of these? Y is our vertical variable, so y is r. What is x? X is our horizontal variable, so x is L. What is b? B is our vertical intercept. That's where the line would intersect the y, or in our case, r axis. And what is m? M is our slope. M is our rate of change, whether we're increasing or decreasing every time we add an additional unit of x, or in this case, an additional worker. What is the change in y, or in this case, the amount of resources, coal, that we need? So what I want you to be able to see is that we could, and we will, rearrange this equation over here to be in terms of r. Because where this is y, our vertical axis equals this formula, we could say r, our vertical variable, equals some formula. So to do that, let's get everything over onto the left-hand side, except for the r. So we'll minus 20L from each side. So we get 40 minus 20L, and 40 minus 20L, that equals 10R. Continuing our algebra, we want to isolate R altogether. So to isolate R altogether, we're going to divide both sides by 10. 40 divided by 10, that's going to give us 4 minus 20L. Well, what's 20L divided by 10? Well, 20 divided by 10 is going to give us 2L, and that's just going to be equal to R. Now, okay, this seems a little bit weird because we have the equation on the left-hand side and the variable on the right-hand side. Here we have variable left-hand side, equation right-hand side. We can just rewrite this the other way. We can just go, hey, instead, let's go R equals 4 minus 2L. And essentially what we've just done here is written y equals b minus mx. That is to say, what our value of r is, well, that's the vertical value. 4, that's our vertical intercept. -2, that's our slope. L, that's just the value on our horizontal axis. We can now plot this. We can now go and say, okay, well, first bit here, our vertical intercept is 4. So let's go up here, let's say right about there. I'm just entirely picking a point at random. That is 4. Great. From here, we can go over and say, what's our slope? Well, we have a slope of -2. Just for reference, if you see what we did there, How did we get that -2? That was the 20, which that 20 was our wage, divided by the 10. That 10 was the price of coal. So really our slope in this case is just negative wage over price of coal. That ratio between the wages and the price of our resource, that is what gives us this slope of -2. -2 means that our isocost is downward sloping. One trick that we can use to get our corresponding horizontal intercept, that is where the line crosses the horizontal axes, what we can do is we can take the magnitude of the vertical divided by the magnitude of the slope. So 4 divided by 2, that's going to give us a value of 2. And that will be our horizontal intercept. What we can now do that we have those two extremes is we can connect the dots. And connecting the dots, we have our isocost, such that any combination of L and R that we pick off of that isocost will give us a, well, let me change tools, give us a cost of $40. And let's go now work through our potential answers and see which one is actually the case now that we have something to look at. So the first one here, the intercept of the isocost on the y-axis is 2. No, on the y-axis it's 4. So that guy is false. The intercept of the isocost on the x-axis is 2. Oh, yeah, there we go. This is our x-axis, our horizontal axis. That is 2. So that is true. So there we go. True. Let's check that box. The slope of the isocost is -2. Oh, would you look at that? We got our slope. That was -2. And again, what was that slope? That was the negative of, in this case, the wage over the price, which was 20 over 10, which is -2. So great. That is also true. The isocost goes through the point 2 workers, 1 resource, 1 coal. Well, we can take a look at this. We can say, is this true, by going and just invoking our equation. So what was our equation? Our equation, again, just going back, this guy here, it's kind of been lost in it, so let's just rewrite it so we can see it a bit clearer now. We said that R equals 4 minus 2L. If this is true, if I substitute in 2 for L, I should get a value of 1 for R. But let's see, do I? What is 4 minus 2? Substitute 2 in for L. So that is 2 times 2 is 4. 4 minus 4 is 0. Oh, 0 is not 1. So that is a false statement. And I mean, we didn't actually have to do that. If you are comfortable enough with the graph, we can actually see that right here. This is the horizontal intercept. When L was 2, well, we were intercepting the horizon. That is, we must have had an R of 0. So could have seen it that way too. Okay, that was working through that question, how we built an isocost from our inputs and were able to work through it. Let's go take a look at our last one that we have on this unit here. Okay, so lots going on with this one. Let's read it and figure out what the heck is happening. So we have in the following diagram, you are given 2 technologies, A and B. They can each produce 100 meters of cloth. Technology A uses 1 worker and 4 tons of coal. Technology B uses 4 workers and 2 tons of coal. The diagram also depicts 3 examples of isocosts. We have NM. Let's just go over what NM is. Let's maybe let's do it this way. Let's go NM, and we'll go NM is blue, and let's find NM here. There we go. NM is that guy there. We also have GF. Let's make GF green. I hope that shows up good. There we go. There's our GF going through there. And then finally we have JH. Let's make JH red. And JH is going through as such. And again, that's JH. We'll say that the wage cost and the price of coal are denoted by W and P respectively. And let's read the following statements and select the correct ones. Okay, what I want to get out of this right away is this is, at least in terms of setup, exactly what we just worked through. That is what we have because, and this is the big thing I want you to catch, because coal is on the vertical, that is R, and then because number of workers L is on the horizontal, that is again our X. So again, we just get R equals B minus ML. B is our vertical intercept of each line, and M is our slope. Keeping in mind, if we're set up this way, what is that slope? That slope is the wage rate over the price. So with that in mind, let's go take a look at these questions and see which one fits. So the first one, JH. What was JH? JH was our red line. Corresponds to the case where wage is 20 and price is 10. Well, okay, if wage is 20 and price is 10, then JH should have a slope of negative 20 over 10, or that is JH should have a slope of negative 2. What is the slope that JH does have? Well, we can quickly work that out. Slope is just rise over run. The rise of JH is from 0 to 4. So it has a rise of 4. And as it rises 4, it drops 8. So 4 over 8 is, and again that's negative, that equals 1/2 or 0.5. Ooh, those are not equal. So what do we get out of that? We get, sorry, you are not a correct answer. So our first one is false. What about the next one here? NM. What did we say NM was? NM was blue. Let's change colors to keep it organized. Okay, NM is the only one of the 3 isocosts depicted which corresponds a case where wage is 20 and P is 10. Right away, without doing anything, I can rule this out to be false. And let's say false, and then I'll tell you why. I can rule this out right away because it's saying the only one. And keep in mind, the slope of this is determined by the ratio of wage and price. If we take a look, our blue line and our green line have the same slope. They're parallel lines. So if they're parallel lines, NM can't be the only one, which corresponds to that wage price combo. So because we have a parallel line that must then have the same wage price combo, this can't be true. It has to be false. Okay, what about C there? I mean, it's not linked to C, but the third option. When wage is 10 and price equals 10, the cost of using technology A is 60. Oh no, where are we getting this from? Well, okay, let's go. Remember how we got this? We got that by saying that our cost is equal to the wage times the labor plus the price times the resource. Okay, so what do we have? We have a wage rate. We have a wage rate of 20, And what are we looking at? We're looking at technology A. Where is A? A has 1 and 4. So 20 times 1 plus, what's our price of the resource? Price of the resource is 10 times resources. How many coal are we using? We're using 4 coal. So what do we get here? We get 20 plus 10 times 4, that's 40. Hey, that gives me a cost of 60. Oh, that's looking good. I'm going to say that guy's true. Finally, the cost of using technology B is the same for both isocost JH as well as isocost GF. Okay, so let's take a look at this one. This one's kind of interesting. So JH and GF, they're saying it's the same in both cases. Well, let's go work through this. Let's go work through this and see what we get. One of the ways that we can go about this is we can do it by returning back to this original formula here that we started off with. And I want to do this because although we've been pretty explicit in how we get the slope, we've kind of been overlooking where this vertical intercept comes from. And I want to isolate this out altogether. So again, let's work through that equation. Let me change colors so that we know it's different. Let's start off with this whole C equals W times L plus, that's a plus, P times R. And again, we want to isolate the R altogether. So what do? We start moving everything over. We get C minus WL equals PR. Then, continuing to isolate the R, we divide everything by P. So what do we get? We get C over P equals, sorry, my bad, C minus W over P times L equals R. Again, just to make sure we're clear, this is just saying B minus MX equals Y, where X is our horizontal variable, Y is our vertical variable, M is the slope, W over P. In this case, we've just defined our vertical intercept as C over P. So now here's the whole bit. The cost of using technology B is the same for both isocost JH. Which one was JH again? JH was our red one. So the same for both our red one as well as GF. What's GF? GF was our green one. Well, what we can see is that these guys must have different ratios of price and wage. And we see that cost, that vertical intercept there, for 10, that is coming from the total cost divided by P. It's hard to kind of be sure in this case here then that we have some case for sure always that these have the same costs and not just differing ratios altogether. And I mean, let's just try this. Let's start with JH here. So let's work through JH. We know when we worked through this earlier that JH has a slope of negative 0.5. That is the ratio, the slope, the ratio of wage to price is 0.5. Let's just, because, hey, look at all this, 2010, 2010. Let's just use that to get our 0.5. So that is, let's set our wage equal to 10. Let's set our price equal to 20. Just taking a look at that, that gives us a slope, wage over price, negative wage over price, 10 over 20, 1 over 2, 0.5. So we get the slope of JH. What do we have at JH? Well, we have 4 workers. We have 2 resources, so 2 coal. So let's go wage times number of workers. I just said we have 4 of those guys. Coal, number of resources. We just said we have 2 of those guys. So like we have in our equation up here for total cost, wage times labor. Wage times labor, 10 times 4 is giving us a cost of 40. 20 times 2 is giving us a cost of 40. That gives us altogether our cost of JH of 80. Great, so we got our total cost in this case for JH, presuming that that is for that wage combo of wage 10, price 20. And actually, if we take a look at it, we actually know that that's kind of what it was drawn for. And how do I know that? Well, like I said, we know that CP here, CP is that B value, that vertical intercept. And we see that, hey, we have a vertical intercept at 4. What is C? C is 80. What did we say the price was? Well, we just made up a price of 20. 80 over 20, that there gave us, well, 8 over 2, gave us 4. So, hey, we did actually just work out JH for what JH actually is. Well, let's see if we can do the same thing for GF. And GF is in green, so let's go work through that. Okay, so similarly what we want to do, wage and price, let's take a look. In this case, GF, well, we have a slope of, we are losing 10 in order to gain 5. So wage over P, 10 over 5. Well, that's not necessarily what wage and price are, but that's the ratio of wage and price. 10 over 5, we get a ratio of 2. Oh, hey, look at that. We already had a ratio of 2, and that's when wages were 20 and price was 10. So let's go work through. Wage of 20, price of 10, and again, this is still at technology B, so that's labor of 4, and our resource is the amount of coal that we're using of 2. Going through this equation again to get our total cost, W times L, 20 times 4, that gives us 80, 10 times 2, that gives us 20. This gives us a cost of 100. Oh, hey, look right there. Just by picking values for W and P, we've gone and shown they have different costs. And in this case, this is a contrived example. There were ways that I could have made it more specific. It did work out, but again, this worked out because I know what I'm doing here. But again, this is what we worked out for this line. We can see for GF here that we have this vertical intercept, this value of B of 10. Again, we've said, hey, B should be total cost over price. And what's our total cost? C over P. So that is 100 over 10. And that should give us a value of 10, which, sure enough, that's the value of our vertical intercept over there. So again, we figured out this line. So again, contrived. There are ways we could have done the algebra to figure out that price for sure, but kind of waved my hand so far at that point there. Anyways, this was just really the very longhand explanation as to why the cost of using technology B is not the same for both of those isocosts, because they are just reflecting different ratios of wage and P. So even though both isocosts cross through that line, cross through that point, they don't actually have the same cost because they're different isocost curves. Hope that helps work through these examples. Of course, like always, if you have any follow-up questions, if any of this wasn't quite so clear and I need to go through it again, please leave a comment below or send me an email. Thanks. Until next time.